All right. So starting with paragraph 9 from the text Far From Shore. Currently, scientists closely monitor, which means watch, the tuna fishery. Now, most tuna fishermen allow the dolphins to escape before they drown, sometimes with a swimmer in the net to help the dolphins escape. That sentence makes me want to know more. But dolphin populations are not recovering as quickly as predicted, and scientists do not know why. Does capture cause stress that lowers their survival? Or perhaps overfishing and population, combined with shifts in climate, which shifts means changes in climate, which is our temperature and weather, may be affecting the balance of the ocean ecosystem. With long-term monitoring, which is watching, combined with ecosystem studies, we hope to understand why these populations aren't recovering at a faster rate. So we have a spotting helicopter here. We have a bird flock. This is the boat. There's a lookout crow's nest, which is at the very top. Somebody sits there. If you remember to Pedro's journal, that's the person who's that sees the land. Power skiffs, which I am not sure what they are, but maybe these little boats. Here we have dolphins escaping over the edge of the net, and then the net/purse. So this is the net that they're using to catch the tuna. And the tuna are at the bottom. Now, I know we've all watched Finding Nemo. We really have to think about that when they're like, swim down, swim down. So the tuna purse seiner hauls in its net. The yellow skiffs round up the tuna and dolphins into the net. As the net is drawn closed, the tuna dive down, and the dolphins swim out. A helicopter and a manned crow's nest, a lookout platform at the top of a tall mast, are used to spot distant tuna schools. Bird flocks are often a clue that fishermen look for. Okay. So there's a helicopter. They're looking for birds because when they see the birds, they're thinking tuna is close by. All right. Finally, we are ready to leave San Diego. Before each long journey, there is always a sense of anticipation, which is like a worry and excitement all at once. What will we see this time? There is, however, a downside to every long trip. I know I will miss my home, family, and friends. The heading right here is actually called heading south. And the subheading is the coordinates. So if you were looking at a map, you could find it based on these. Over the next days, we move off to shore and head south to warm tropical water. Our route, which is our path, takes us south of the Hawaiian Islands. In a few weeks, after a month at sea, we will turn and head north to Hawaii to resupply and fuel the ship. The ocean color has changed since we have left San Diego. It is a beautiful clear blue. I look down through the water and it seems as though I can see for miles. Here the water can be much more than a mile deep. It looks nothing like the ocean near the shore off California, which often has a murky green or brownish cast to it caused by lots of plankton and algae. Plankton and algae are in the water. You guys watch SpongeBob. You know what plankton is. These are little living creatures, and algae is a very small plant that's kind of green that grows on the tops of the water. It says the tropical ocean is clear because it has much less of these. And now we have, I'm going to pause for just a second so I can zoom out. All right. For some reason, I can't, I had to move this out of the way to get it smaller. Okay. So I'm going to actually read the caption first. This net called a bongo because it looks like the drum, is used for catching small fish and plankton. Some creatures frequently caught in a bongo toe are pictured here clockwise. A spotted larva squid. So that's this one. And if clockwise, we go this direction. a semi-clear larval octopus, which is this one, and krill, which are this one. Krill are small relatives of shrimp and are an important food for whales and birds. Okay, so this is the bongo. It's 5 meters, which means 16 feet. So that's like me standing on my shoulders 3 times. Cod and collect sample. Okay, so it looks like things swim in here and they get caught down here. Interesting. Paragraph 12. Where there is water, where there is food, there are animals. In the tropical ocean, animals tend to be found in patches where there is more plankton and algae. Small fish and krill eat the plankton and algae. Larger fish and squid eat them, and so on up the food chain to tuna and dolphins. One of the things we want to understand is what causes this patchiness. Okay, we combine our marine mammal and seabird observations with measurements of water, plankton, and algae. Every morning, an hour before sunrise, and every evening, an hour after sunset, we collect water samples from the surface down to 1,000 meters to look at the water's nutrients and chlorophyll. Chlorophyll is I actually don't know how to explain it, but it's a natural occurring thing in plants that makes them turn green. These nutrients are the building blocks of the ocean food chain. In the evening, we also deploy, which means throw them out, nets to determine the amount and types of plankton at different depths. How deep? So they put them at different, going down this far, then going down this far, and then down this far to see the types of things they can find. We use dip nets to catch flying fish and squid. All of this information helps us to have a more complete picture of the ecosystem of the tropical ocean. Oh, look! Chlorophyll, a green substance found in plants that allows them to make food. Wow, that's handy dandy to have right over there. Now I know what chlorophyll is. Okay, before I go on to the next section, we're going to look at this graph. Over here, it says it's a graph of water sampling showing measurements of oxygen, temperature, and salinity, which is the amount of salt in the water, from the surface to 1,000 meters, which is the same as 300 feet. As one follows the graph from 1,000 meters to the surface, note the drastic changes at the depth of about 100 meters. Oxygen and temperature increase sharply as salinity decreases. Okay, this is where 2 different water masses meet, and it's called a thermocline. A thermocline that is strong and close to the surface can indicate a highly productive area where we might find not only a large amount of algae and plankton, but also animals much higher in the food chain, such as dolphins or tuna and dolphins. Okay, that was kind of hard to understand, but they're saying right here is like the sweet spot. It won't let me do anything. Right here, that's where you get the perfect temperature, the amount of salt, and all those nutrients in the water for you to find dolphins and tuna. Typically, as you go deeper, you're not going to find tuna and dolphins. All right, I will start my next reading in just a minute.